51. It says graph. The graph shows the attendance at a hockey game and the rate at which the fans enter and exit the arena. Compare segments 1 and 2. So what we're looking at is we're looking at segment 1, that's this little strip here, and segment 2, that's this little strip here. It says, what do they represent? So just briefly, let's talk about what does that mean. What does that mean, guys? Segments 1 and 2, what's going on there?
It's showing the graph.
The number of people in the amount of time.
The number of, I'm recording, so when I send you to the office, I can just play this video, and they can see that you're not paying attention to me teaching and explaining and asking questions. So I'm going to ask the question again. The graph has the attendance of a hockey game at an arena. And hold on. And it says the graph is the rate in which the people enter the arena and how they leave. So it says compare segments 1 and 2, and a couple of things were stated. One was it shows the people entering the arena, the number of people, and the time. So if we wanted to put some information there, what I could say is that from this little dot here, from here down to here, let me make that a little bit more like this. From here to here, that is the beginning from here to here. That's segment 1. And then from here down to here, from here to here, this is segment 2. So this is 0 to segment, this is segment 1, this is segment 2. Now, it's showing the number of people that come in. So right here, the number of people is 0. Now, I don't know how many people come in here, but I know at the end of segment 2, more people come in. So the higher up you go, the more people come in. And what does it mean? What does it represent? Well, it shows that a lot of people from here to here, a lot of people come into the arena. Almost half the people that are in the arena come in during segment 1. And then some more people, but not as many with regards to rate. It wasn't as many people in the same amount of time, because when you look at the time, segment 1 and segment 2 are about the same distance in the x direction, right? And y represents the number of people coming in. So it says, what do they represent? Well, it represents how many people enter the arena. So you just put enter arena. And segment 1 has way more people than segment 2. And then it says, what does segment 8 represent in terms of the game? Well, what happens here at segment 8? The game ends. I would guess that from here to here, somewhere in here is like a halftime or something, because nobody enters and nobody leaves. A few people leave, and then nobody leaves after that. So I would say segment 6 is probably like a halftime break. And then some people are like, well, I'm going to go because I know who's going to win the game. But probably segment 8 represents the end of the game. So when the game ends, notice that everybody leaves the arena. Now, what about segments 5 and 7? 5 and 7 is the game. Nobody's leaving, nobody's entering. So I'm going to say game is going. I should say ongoing, but there's not a lot of space here. What do you think segment 6 represents? Well, I would guess that segment 6 is probably like people not leaving the game, but probably like a break, right? but how do I word that? Probably like some sort of break, like a halftime. I don't watch hockey. Does anybody in here watch hockey? Do they have like a halftime?
Yeah.
So I would say break or like halftime, and then a few people decide to leave. Maybe the score. So during that break, a few people leave. In other words, when we look at this, this is the number of people in the arena. Something happens, and a bunch of people have time to leave, and then nobody leaves or enters, and then all of a sudden everybody leaves. Okay. So now let's move on to graphs A through D. Exercise 5 through 8. Janelle alters between running and walking. She begins by walking for a short period, then she runs for the same amount of time, then she takes a break, and then she begins to walk again. And we got to figure out which graph represents that. So I'm going to say C. Do you guys know why I said C? Well, she's walking. So when she's walking, she's creating some distance, but not as quickly. So the steepness of the line represents her running. So this very steep part, she's running. Here she's taking a break. She's not moving at all. She's just kind of catching her breath. And then she's walking again. In other words, she's creating some distance. She's moving some distance, but not as much as she is when she's running. This first one, and let's look at this. This one is a steady speed the whole time. You can't even do that in a car hardly. This is saying that she walked at the same distance the whole time. This one, she's running, then she walks, then she takes a break, then she runs. This one, she starts off very slow and gradually increases her speed and increases her speed and increases her speed. So 5 says, which graph best represents the situation? C. Describe the other graphs I just did. A is a constant rate. B, she ran. That's not a very good B, is it? B, she ran, or she would run, walk, break, and then run again. And then D, she started slow, and increased to fast. What if Janelle began by running, then slowed to walk, then stopped and began running again? Which graph would represent that situation? Well, that would be B. And what are possible situations for A and D? Well, A is kind of steep, so A would be, like I said before, she ran at a constant rate, or she could walk, but it's a constant rate. D would be that she starts real slow and starts walking faster and faster. And she starts walking, so for D, she kind of walks and slowly increases her speed and runs really fast. Okay. Any questions on that? Let's try to do this last one. What time do we get out of here? 45? Yeah. We could try to do this last one real quick, or 48. I think we could finish this last one. It says graph A through D, exercises 9 through 11 during the winter. The amount of water that flows down a river remains at a low constant. In the spring, when the snow melts, the flow of the water increases drastically until it decreases to the steady rate in the summer. The flow then slowly decreases through the fall and winter. So which one do you think that is? You think it's A? What do you guys think?
No. D.
Well, let's read it again and we'll double check. It's not B, because B is showing that the rate increases. It's a steady increase the whole time. So it's probably not B. It might be A. This one is a constant rate the whole time. Never changes. When you see a straight line, that's a constant rate of change. It never changes. That's not what was described. So the question then is, does it increase or decrease? So it says in the spring, the snow melts. So it says during the winter, the water flows downriver at a very low constant. In the spring, when the snow melts, the flow increases. So it is A, yeah. So here, what they're saying is this increases, but it goes very slow. Then all of a sudden, it gets real steep, and then it drastically slows down for summer, and then in winter it freezes again, and then it melts a little bit. So A is the actual thing. So that's the graph A. Describe the other graphs. Well, for graph B, it just, the rate gradually increases. So the rate gradually, I'm going to put B, rate gradually increases. It just the water keeps flowing a little more and a little more and a little more till it's really flowing. Now for C, I'll just write it up here. C, what it's doing is it's a constant rate. Whatever the water's flowing in the winter, it's flowing the same in the summer, the same in any time of the year, from winter to fall. For this one, it starts at a steady state and then it decreases, then increases. That's the exact opposite. So here it's slow or low. It's a low rate. I'm going to zoom. Let me zoom a little bit so you guys can see it a little better. Whoops. So from here to here, it's a very low rate. Then it slows down. Then it's a low rate. Then it decreases. Then over here it increases. And then here it slows down again. Slow or a low rate. Which is the opposite of what they said. In the scenario for A, it increases when the water melts at the end of winter. And I probably should point out that on all of these graphs, this is the winter. About 1/4 of the way is the spring. About halfway through is summer. This is fall. And then at the end, it's winter again. So that's what's going on. Any questions on that? I wonder if we could finish. No, we can't finish the next one. So let me pull this back up so you guys can see it. I'll leave this on the screen.